Very good afternoon. Myself Dr. Ruchi Gupta, Associate Professor IT Department. Today we will discuss a topic about software engineering, that is software problems, software quality attributes, software myths, software crisis, etc. As we have discussed in the previous lecture that what are the various characteristics of the software. Now, today we will discuss software problems. So, there are certain problems with the software, as we know that software is very dynamic in nature, but still there are some problems with the software. So, the first problem is about the software is expensive in nature. So, it is our myth that software is very low cost softwares, but no, softwares are very expensive in nature, as we have to compare the cost of software with the hardware. So, this is a curve of software versus hardware cost. So, this is a software development cost and this is your software maintenance cost. As we have seen in this diagram, there are two costs, software development cost as well as software maintenance cost. So, as per the survey, the 70% of the cost of the software is included in the maintenance part and only the 30% of the cost involved in the whole software implementation process. So, in all about the 100%, only 30% cost is involved in the implementation part and the rest of 70% cost will involve in the maintenance part, because as per the survey, as per the standard survey, a standard software implementation time duration is about 2 to 3 years, while the maintenance phase of the software is about 10 to 15 years. Why? Because till the time software is being in the maintenance phase, we have to upgrade the software. We will upgrade the software till the time it will in the maintenance phase, and the maintenance time of the software is about 10 to 15 years, because after 10 to 15 years the technologies will completely change. So, until the technologies completely change, or till the time the software is flexible for the modification, it will upgrade as per the technology change. We may change. So that the maintenance cost will high as per the implementation cost. So that we can say that software is expensive in nature. Now, the second problem with the software is softwares are late, costly and unreliable. So, it is late, costly and unreliable because why? Because suppose if we have to take the requirement at the very initial phase, when we have to take the requirement from the customer. So, this is a definition phase. So, at the time of definition, suppose we have to put that the cost will be 1x as per the requirement of the customer. It means we can say at the very initial phase that the cost of software will be 1x. But once the software will actually go into the implementation phase and we have to use the resources, various resources as per the requirement. So, the cost may increase 1 to 1.5 or 1.6x. This is the cost during the development phase. And once the software is at the last phase of SDLC, that is in the maintenance phase, so after releasing, there may be a possibility that the cost will be increasing proportionally. It will exponentially increase it up to 60 to 100x. So, the cost of change, if we have not if we have not calculate the resources properly at the very initial phase, then in that case the cost of software may be increases. So, this is one of the problem with the software. Now, as per the cost report, this is the cost report. Statistics says that there are 3 out of 100%, there are 53% softwares This is the category of cancelled project, delivered project on with some limited requirement. The red part, it will show that the 31% softwares may cancelled before they implement, and this blue part, that is 16% projects are only 16% projects are to be delivered on time, on budget, with all specific requirement. So this is the survey that the only 16% projects are to be delivered on time, on budget, with all specified and with all features and functions to the customer. If we have seen here that 31% projects are to be cancelled before they were completed because there are some lacking of at the very initial phase. Either we have doesn't understand the clear requirement, either we have not collect the resources, either we have not a manpower. There may be whatever the reason, but they may cancelled. So this is 30%. Now we come the 53% projects are to be delivered, but they are with some limited functionality, they are with some over budget, over time, and over schedule, or with some fewer functions or fewer requirements. So it is the problem. It is a problem with the software that only 16% of the projects are to be delivered in the market. If we are talking about the real world scenario, that only the 60% projects are to be delivered on time only. Now, this is another problem with the software, the failure curve. If we have to compare the failure curve of hardware and software, that this is a bathtub, as I have already discussed in the characteristics also. The software curve may vary. It may vary. There are some up and downs in the software curve, because the hardware curve, it is a straight curve. So, and the dash curve is a software curve. If software never change as per the technical requirement, as per the technological requirement, then it will deteriorate it. It will deteriorate it gradually. Means if we have not changed the software as per the requirement, then it will be deteriorated gradually. And if we have to change as per the requirement, as per the real time environment, if we have to change the software, or if we have to upgrade the software, then the performance will increase, otherwise it will decrease. When we have to upgrade, then again increase, then again decrease. So the curve may be up and down. It shows up and downs. Now, another problem with the software in the maintenance phase, when we have to change, when we have to modify the software, or we have to maintain, or we have to rework with the software. So it is another big problem with the software, that is problem of change and rework. So once the software is delivered and deployed, it enters into the maintenance phase. As we have already discussed the complete SDLC life cycle in detail in the next lecture, that there are certain phases of SDLC: analysis, design, coding, testing, and maintenance. So after testing, when the software is ready for the deploy, it will go on to the maintenance phase. So once the software delivered and deployed, it enters in the maintenance phase. It will go into the maintenance phase. So maintenance work is based on the existing software as compared to the development. We have never create a new software in the maintenance phase. We always upgrade or modify the existing software in the maintenance phase. So as I have already discussed, the cost of maintenance is much higher. It is we can say it is a 3 times higher than the cost of software implementation. So the complexity of the maintenance task coupled the neglect of the maintenance concern during the development, it makes maintenance most costly activity during the life cycle product. So maintenance is the most costly activity during the whole process, and maintenance is one form of change or rework that typically is done the software development is done when the software implementation is completed and software is deployed to the customer. Now, we come on the software crisis. Crisis means it is not a problem of the software. Crisis means the software is okay, the software is correct, but due to some crisis, software is not available. So, this is called software crisis. So, as per the survey, 20% of the client server applications are abandoned or restarted from the scratch. Means due to some problem, 20% applications are to be started from the very initial phase again. Now, 30% of the applications are significantly altered or avoid some disaster problem. And 50% of applications are delivered, but they are significantly late due to any reason. So, we can say that suppose I need a software today, but due to some reason, it will not available. It will available after 2 or 3 days or 1 month or 2 months. So, it means we can say the requirement is now, but it will available after some time. So, this is the crisis with the software. Now, we come on the quality of the software. Software, what is software quality? Because when we have to develop the software, so we also consider the quality. Quality in terms of budget means we can say that if we are deliver the software on time, on budget with all specific requirement, we can say that software is a qualitative software. So, what is the software quality? As per the IEEE definition, IEEE standard, the definition of quality is that the degree to which a system component or process meets the specific requirement, or the degree to which a system component or process meet customer or user expectation. It means we can say that if the software meet all the specific requirement of the customer, because ultimately the software is designed for the customer. So, if meets the expectation of the customer, then we can say that software is a quality software. So, when we have to implement this software, then we have to consider the various quality attributes under this category. So, there are basically 4 domains of software quality. One is the reliability, usability, then maintainability and adaptability. So, under the reliability, there are 5 attributes under this category: reliability, correctness, consistency, robustness, simplicity and traceability. Similarly, under the usability domain, there are certain attributes: accuracy, clarity, conformity, completeness, efficiency and testability. Now, there is a third domain, attribute domain, that is maintainability. Under this maintainability, there are 4 attributes are there: accuracy, modularity, readability and simplicity. Now, under adaptability, there are 3 attributes: modifiability, expandability and portability. Now, this is the description about all the software quality attributes which are to be considered during the implementation of the software. It is necessary that it is, we always kept in mind that quality is to be considered during the whole implementation process. We never consider the quality at the end phase. We always consider the quality during the whole process. So, all these quality attributes are to be considered during the implementation of the software. So, the first attribute domain is reliability. Reliability to the extent to which a software perform its indeed function without failure. It means we can say if our software is perform well without any failure or without any error, it means we can say that software is reliable. And when it will reliable? When the software is correct. This is the first attribute. the extent to which a software meets the specific requirement. If it meets the specific requirement of the customer, then we can say it is correct. Consistency, the extent to which a software tolerates some unexpected problems. It means it is robust. The extent to which a software is consistent and it gives a perfect results with precision, then we can say it is a consistency. Simplicity, the extent to which a software is very simple in operations. It means when we have to implement the software, then we have to keep in mind then we have to implement the software in a very easy way without complexity. Traceability, the extent to which an error is traceable. If the code is simple, then we can easily trace the error. Usability, the extent, effort required to learn, operate and understand the functions of the software. Now, accuracy means when the software meet all the specifications with some precision, then we can say it is accurate. Next is the clarity and accuracy of documentation. We also consider that with the implementation, some documentations are also required. So, the extent to which the documents are clearly defined, if the documents are accurately written, then it means we can say there is accurate. Conformity and operational environment, the extent to which a software is in conformity in the operational requirement. Completeness, when we say that the software is complete, the extent to which a software has a specified function, it means if the software is having all the functions or features as per the customer requirement, then we can say it is complete. Efficiency, the amount of computing resources and code required by the software perform a function, then we can say it is efficient. Testability means the effort required to test a software to ensure it's perform well as per the intended functions or features. Maintainability is also another domain of this quality, the effort required to locate and fix the error during the maintenance phase. Modularity, it is the extent to easy to implement, test, debug or maintain the software. This is come under the modularity. Readability means software is readable and it is easy to understand. It means if any user want to understand the code as well as documentation, they can easily understand. Adaptability, the extent to which a software is adaptable as per new platform or technology. Adaptability means suppose if after some time if the technology is being changed or if there is a need of portability of software from one platform to another platform, then it means your software may be in the flexible. If your software is flexible, then we can easily port the software from one platform to another platform. Modifiability, the effort required to modify the software during the maintenance phase. So, the extent, expandability means the extent to which a software is expandable without any side effect. It means we can say that if there is a need, if we want to extend this software or if we have to expand our software, then if you have to restrict your software at very initially, so you never modify or you never upgrade your software, you never expand your software. So, we have to keep in mind at the time of implementation of the software, then we have to generalize all these things. We have to generalize so that we can easily expand our software. Now, portability, as I have already discussed in the adaptability, that if there is a required to transfer a program or software from one platform to another, we can easily port, we can easily port the software from one platform to another, but the condition is if the software is compatible with that particular environment, then only we can port, otherwise we cannot port. Now we can easily understand the difference between program and software, because we have already discussed the concept of program and we already discussed the concept of software. So now we can easily differentiate between program and software. So the first one, if we are talking about the program, programs are usually small in size. It means if we have 100 line of program, we have write 1000 line of program, 10 line of program. But if we are talking about the software, softwares are very large. They are millions and millions lines of programs, or it is a collection of programs. Another one is author himself is a whole soul in charge of the program. Means the author will write a program. That author is only responsible for testing or maintenance of that program. But in this software, it is not true. Basically, a software, it is a teamwork. So there is a team is to be decided for the implementation, for analysis, for designing, for testing, or for maintenance. It is a teamwork. Single developer, as I have told here, that it is a team oriented work. So in the program, we can only there are only single developer can implement the program, but it is a team of developer. Now in the program, there is a lack of proper user interface. Means directly we can implement the program without analyzing or designing, but it is not acceptable in the software because it is a well designed interface. How we can say it is a well defined interface? Because once we have to complete the first phase of SDLC, that is analysis, then only we can go on to the next phase, that is designing. It means we can say the output of the first phase, it become the input for the next phase. It means there is some interface between phase 1 and phase 2. Similarly, once we have to complete the second phase of SDLC, that is design, then we only insert into the next phase, that is coding. So there is some interface between design and coding. Similarly, there is an interface between coding and testing. Similarly, there is an interface between testing and maintenance. So well-defined interface between all the phases of SDLC. In the program, lack proper documentation, or we can say that there is no need of documentation once we have to implement the program. But in this software, there is a proper documentation is required. As we have seen that in the first phase of SDLC, we have to prepare the SRS, software requirement specification document. In the second phase of SDLC, that is design, we have to prepare the design document. In the third phase of SDLC, that is coding, we have to prepare a list of programs. In the fourth phase of SDLC, that is testing, we have to generate the reports, and in the last phase of SDLC, that is maintenance, we have to generate the maintenance reports. So there is a proper documentation required in the software. In the programs, it is a ad hoc process and it is a systematic approach. As I have already discussed that it is a systematic approach of development. Means first analysis, then design, then coding, then testing, then maintenance. So it is completely a systematic development process. Now, what are the myths about the software? So as we have to see as per the customer point of view, what is the customer perspective? So a general statement of objective is sufficient to get started with the development of software. So customer perspective is that if there is some missing or vague requirements can easily be incorporated, but it is not true actually. It is very difficult to work on some missing requirement. It is very complicated task. Software is very easy to change. No, it is not true. Software is very complex. software is more feature is a better software? No. Limited feature software is also a best software. It may be a best software. If we have see as per the developer perspective, so as per the developer perspective, once the software is demonstrated, the job is done, but it is not true always. Second, the only deliverable for the software project is tested code. No, it is not always true. Until the software is coded, it is available for testing. No. As per the management perspective, management thinking is that as long as I have good standards and clear procedures, I am always deliver a good quality project, but it is not always true. As long as my software engineers access the fastest, the most sophisticated computer environment or tools, I should to be concerned, but it is also not true always. Now, there are some terms about the software project, product and process. So, sequence of tasks planned and beginning to the end of boundary, outcomes and deliverables, these are the projects. What is delivered to the customer, it is called product, and process, the way, the method through which we have to develop a software, it is called process. Now, this is the dependency role of management in the software development. Pupil, there are 4 P here: pupil, product, process and project. So, this is the dependency level: first pupil, second product, third process and fourth is the project. So, these are the factors of management dependency from pupil to projects. These 4 P's are involved in the whole project implementation process. So, this is all about the software and programs. Thank you very much.